Hi and welcome to this webinar about IFCs and CostX. Last month's webinar, Subcontractor Comparison, was conducted by Gavin and it was part 5 of that series. This webinar will cover IFCs, what they are, the benefits and challenges, and how CostX can overcome some of these challenges posed by IFCs. We'll look at the CostX itself with a live demonstration with some models from Tekla and Revit. To review this webinar later, you can visit exactor.com/webinars. So straight into it, what is an IFC? It stands for Industry Foundation Classes. It's authored and maintained by Building Smart. It's an open data model based on class definitions for building objects with relationships between elements, spaces, properties, shapes, and attributes. The current version we're on, IFC 2.3. IFC 4 was published recently but is yet to be implemented widely. And it provides a universal platform for systems to exchange information. Okay, so what are the benefits of an IFC? First one, a neutral file format. So just like Revit, it has internal rules to express a relationship between a wall and a window, for example. An IFC specifies a neutral representation of the same relationship, but based on its own geometry and data standards, which are called step and express. And the purpose of the IFC is to provide this neutrality between different systems. So the next point, import and export. IFC compliant applications can either export, import, or do both. They may also reuse or edit the data. And because IFCs are an open standard data model, proprietary data models like that come from Revit, MicroStation, and ArchiCAD need to be mapped or translated to IFC categories prior to their export. So a certain type of internal door must be mapped to IFC door as a basic example. And how a model is prepared for export is extremely important and is a critical factor in the ultimate success of the IFC exchange process. So in Revit and ArchiCAD, it's essential to ensure that objects are mapped to IFC categories, which may involve override settings and creation of IFC specific parameters. Also, the inclusion of model quantities as property sets can be used, which you'll see as PS set in CostX. These can be very useful, which we'll just come on to in a second. IFC data instead of native data. So the IFC is not an exact copy of the authoring data model that you see in Revit, for example. It's actually an alternate representation based on its own specification to the IFC schema. And then we have different MVDs. These are IFC exports, how they're governed and how they can be exported as a subset, so it contains the data specified for a particular use or exchange scenario. So a structural engineer would require a different view to the QS. A 5D QS using CostX would expect to be provided with IFC 2.3 extended coordination view. Next point, property sets. These can be used to include dimensional instance properties. So these are more useful in comparison to base quantities. Base quantities are actually calculated from the model geometry as part of the IFC export process, whereas property sets can be used to export explicit dimensional properties if they have been mapped and categorized, like we've noted above. So the main point of all of this is to outline the importance of the export and how these challenges can be addressed at the source by the designer. So if you can provide your architects with our drawing file optimization document, this is general guidance on exporting 2D and 3D files from various design packages. So instead of having generic disadvantages for an IFC. I've concentrated it on the 5D challenges of an IFC. The first, we have managing objects, and we have large amounts of irrelevant information, the extent of quantities, adjoined descriptions, and data loss. And I've put this into a table and showing on the right here how using CostX we can overcome some of these challenges in an IFC. So if we start with the first one, managing objects, I'm going to open CostX. So managing objects, if we come to the model tree just here, you'll notice if I expand some of these branches, you can see that we'll have more of a classification and sub-branches. So to assist in model navigation, CostX generates a hierarchical model tree based on these IFC friendly subtypes, which act as an identifier for objects within each element. Why this classification is so useful is because when model mapping, the grouping of the objects makes this a much more easier task. You know this if you use DWFs. You'll be familiar with this sort of classification. So this alone sets CostX apart from other applications in the way that it reads the data. Okay, so another way to manage objects, if I show all, I can use the right click context menu to show only objects in an IFC beam. And this is comprised of a few different objects. If I look at this beam, you can see we have a purlin there. If I go further into detail, so show only objects in rafter, again you can see some other objects like the haunch, the purlin cleat have been included with this rafter. So what if I just want to isolate these particular beam nodes? What I can do is use the custom filter. So I show only objects in custom, and here I'm going to choose rafter, and then I've got a friendly type name here, beam. So when I click OK, you notice that I've now got rid of the other objects that I don't need. So now if I want to measure these, I can right click on the object and create a dimension group. I'll call these rafters. Okay, so I'm going to measure these as a volume and display it as a weight. I'm going to put the weight unit of measure here in kilograms. Then I can use the BIM dimensions here to select the length, volume, weight, and outer surface area just here. Insert that, and a couple of ways I can do this now. I can right click on the object, import objects in custom, and then select those two how I just showed them. That's one way. Another way would be to just import objects in an area, and I'm just going to draw this box around those objects, and you can see there I now have a weight of 1171 kilograms. If I wanted to convert that to tons, I'd come to my dimensions here, change the unit of measure, divide this here by 1000. So now if I open this Revit model, we're now going to address the second challenge, which is large amounts of irrelevant information and columns. And the way we can manage this information is opening the schedule. So you see these 5 dots here, I can use this to drag up the schedule like this. or I can use schedule here in the dimensions tab to turn it on and off. Okay, so way I can sort through this information, you can see I can use the scroll bar to check what I have available, but you see many blank columns or just irrelevant information that I have. So I can use the star button here to show or hide columns, and I can use this to untick a few. This is quite long-winded, so what I could do instead is right click the column heading, any column heading, and hide all columns. Then I can click on the star again, and now I can just click on the information that I need. Rather than having to sift through all the information. Okay, so that's one way to do it. If I right click it again and show all columns, another way to do things is to click on the star again, click off or untick all of the columns that you require. So I'm just going to do a few, and then if I right click, I can invert the column selection, and this will only populate the boxes and properties that I unchecked. So this is a really nice way to sort of clean up the schedule and information in an IFC. And further to that, it provides an easier way to manage these properties when creating a model map. So you can see what you need and then add to it if you wish. So for the next challenge, what are the extent of the quantities, if any are available? I'm going to open up this ArchiCAD model. Close the schedule, and in fact this is the object that I want to interrogate. So if I lift up the schedule, again IFC slab. Okay, so I want to check the extent of the base quantities. So in particular, the gross area and the volume. So the first way is using the measure distance button or the M key on the keyboard, which is the same thing. And I can use this to check one length. If I hold the control key, click once and then draw the line, and I can use that information there. For my area, I use a calculator, hold control again, now checking the depth. So I can use that information that I have to check the extent of the base quantity, gross, volume. Another way to do that is if I add a dimension group and say slab check, I'm going to display it as a volume, and I put the default height here of 200 millimeters, which I'm going to insert. So the first way would be hold the shift key, and you can see there now we have an area of 1.02, which links up to that, which is fine. And also if we have a look at the volume there, 0.2. So this is a very simple example of checking, but I'm going to stress the importance of checking the quantities in a model, especially in IFC, because base quantities, they come from the IFC export process. So an IFC creates these quantities rather than it coming from ArchiCAD or Revit or Tekla. So use these base quantities with caution. If we open up this Revit IFC, I'm just going to isolate this IFC wall standard case. If we have a look at the schedule here, again we've got footprint area, side area, volume, height, length. I've decided that I don't want to use them and I just want to measure directly off the model. So with CostX I can use 3D measure mode, which allows you to measure areas and lengths of objects to determine physical lengths and areas of the model rather than relying on any information in the model. So I'm going to put a stone finish to these external walls. I'm going to have an area and insert that. So the way I can measure the surface area is by clicking in point mode, hold the shift key over one face, the shift key followed by the control key, and then left click, left click, left click, and you can see how I'm creating one continuous area. If I do the same for the other, so shift followed by control, and then let go. So we can see we've got one continuous area for the wall stand case I've got here. If we now have a look at the dimensions, you can see I have two quantities rather than a single quantity for each and every part of this wall area. Okay, on to the next challenge of IFCs, which is adjoined descriptions. We can use functions like x number, left and right x get text. The ones in particular what we're going to look at is x number and left. So if I edit this model map, we can use functions in model maps to separate strings or try and pull out values which we require. So for this particular group of objects, universal beam, I want to be able to take text from it for my dimension group. So let's use this as an example. IFC beam level 1 as my folder. Fine. The dimension group, you can see here, I want to just use from the beginning of this UB to 102. So the way I can do this is use the left function. So if I type left in the dimension group, open bracket, drag in my level 2, and depending on how many characters it is from the left, so it stops here around 25, so I'm going to put 25 from the left. If I preview this, you can see it gives me just that part of the string. Now for another function, we're going to calculate the weight of these universal beams. So if I take the length and just pop it here, and I've got this weight value here. So at the end we've got 28 UB, so it indicates 28 kilograms per meter. So how do I get that 28? What I can use is x number, open bracket, bring in that property, and it's the third number I want. So 1, 2, 3, 28 is what I want. So I'm going to go level 2, comma 3. So now I've got that 28, which is in kilograms. I'm going to times that by the length, but the length is in millimeters. So I'm just going to convert that to meters. Okay, unit of measure at the moment is kilograms. set the default display here as weight. Preview that. We have 619 kg, which seems about right. So there are other functions you can use, like an if statement, X text. These are all outlined in the advanced manual in more detail if you wish to seek more information. So if I close this model map, okay, on to the next challenge, which is loss of data, which the translation process can involve. For example, exporting an IFC from an application and then re-importing it back in. It may not create the original model in its original format, and certain features may not even work any longer. So to account for any loss of data, it's possible to export the schedule out from CostX and to supplement the model. So if we open up this Tekla model, and just going to isolate the walls, show the schedule, and we're going to right click the schedule and save entire schedule to Excel. I'm going to call it wall schedule. Okay, so I come to the most far right column. I'm going to call it finish type, and I can use the filter on row 1 to now use these parameters to help me when I apply my finish type. So for the profile, you can see here I can select a few of these wall types, and the finish type for these require painting. Next one, these ones require rendering, for example. And these require cladding. Okay, so I can now select all, and I have finished types for all my walls. So I can save this, come back to my drawings tab, edit the drawing properties, and then this properties file name, I can use the dots here to select the wall schedule. And now you'll find as a yellow column we'll have finish type. And then, for example, what we could do is right click an object, show only objects in, custom, and say rendering. So you can now see how we can even group objects afterwards by these user-defined properties, which you can see here and I use custom, you can see my user defined property is now here available for me to check. Okay, so thanks for watching our webinar on IFCs. We'd love to know what your experience with IFCs are. How do they benefit you in collaboration? What challenges do you face with this exchange format? Email support@exactor.com or feel free to phone in on a local office. To view this recording, go to exactor.com/webinars. Thanks.